Good evening, and welcome to our first Make-a-Thon here at CLC. As part of the Lake County Maker Fair, we'll be running this Make-a-Thon for the next 2 weeks to give you a chance to showcase your great creations at the Maker Fair on April 17th. Joining me tonight is Derek Runberg from SparkFun, who's going to take some time to walk us through all those great items in the SparkFun box and talk about the electronics that we have in there. And I'm going to share my screen here for just a second. And I just wanted to talk briefly about what is in your box. And so if you've had a chance to open up the bag, you may have noticed that there's a variety of things. The SparkFun box itself, which has an array of sensors, some motors, resistors, LEDs, and all the things that Derek's going to walk us through tonight. We've also thrown in some prototyping materials to get you started on your creation. So there's some cardboard, some cardstock, sticks, zip ties, the glue guns, glue sticks, the odd little blue guy that you may have noticed. It looks like a key ring. He's a bottle opener, but it's also a tape measure. So if you pull out the one leg, that may help you out as well. And in addition, we've thrown in some information, especially for our high school students, about some great summer camp opportunities, and then some summer camp scholarship information, as well as some scholarships for our college students here at CLC. In addition, you probably came across the Maker Fair t-shirt and a pin that was created in our lab on the lasers. And so with that, I am going to pass things over to Derek to jump in and show us all the great things that we can do with our Arduino.
Perfect. Hi, everybody. It's been almost over a year, and I'm still not used to completely teaching online to a whole group of people. I wish I had faces in an audience, but this will do just fine. So thank you so much for having me. Today we're going to spend about 2 hours going over the electronics in your kit. I'm going to go over what it is, what Arduino is, and what it isn't for those of you that it's new to. And then we're going to go through and build some circuits together and program them. I have a couple of slides also that just share some interesting information, as well as maybe some projects that could inspire you or that you could see maybe building in the future at some point. So SparkFun Electronics, we're an open source electronics company. Think of us like the Home Depot of electronics components. So just like Home Depot, you can go get a 2x4, you can go get cement, you can go get tools. For us, you can come get resistors, LEDs, a Raspberry Pi, an Arduino, or you can buy a whole bunch of stuff. So same thing, we produce content and hookup guides for all of our products, and then help others to learn about how to use electronics. We try to demystify as much as we can. So with that, I'm going to demystify Arduino for you. I'm going to hold tight. I have to switch between about 2 or 3 different cameras. So I'm just going to switch to this one. And I'm going to first go over the components, what's in your kit to begin with. This board, this red board that's blinking, is the SparkFun version of the Arduino. So it's the Arduino Uno. It's called the SparkFun Red board. And we made our own because Arduino is open source, meaning that I can take the design files and I can mix them up, mash them up how I see fit, and then reproduce that design. The red board is the same thing as an Arduino Uno that you might find out there that might look teal or kind of blue. Just we've made a few changes to it. We've added our quick connector to it and some other things. An Arduino is what's called a microcontroller board, or an MCU. This is different. It's still a computer, but it's different than your laptop or computer that you're looking at right now. That runs off of a microprocessor, meaning that it can be doing multiple things at one time. So for example, mine's running 2 webcams, a microphone, and a whole bunch of other windows. A microcontroller can only do one thing and one thing at a time. So right now, the one thing that it's doing is blinking this LED on 13, pin 13. So when we look at an Arduino, we have the microcontroller itself, which is usually the biggest chip on here, which is this one here. You have what are called pins. So these little ports down the side, and they're numbered and labeled. Each one corresponds to, the reason they're called pins is because they correspond to the very tiny little pins or legs on the microcontroller. So pin 13 up here is connected to pin 13 on the microcontroller, which is in this corner somewhere. It's not important. You have a USB connector, which this is how we power it, and we put code on, or program it. There's a reset button. So if anything ever gets stuck here, or I need to turn it on and off and on again, just like our normal computers, I can hit the reset button. And then I can actually power this separately with a barrel jack. So if you built a big project and you didn't want it just connected to your computer all the time, you can actually power it with a battery. And that's pretty much it in terms of what's on here. There's a couple of LEDs. One is on pin 13, and we're actually this is the first thing we're gonna program here is this LED. And then there's a TX and RX LED as well. And we'll talk about those in a little bit. You also have what are called jumper wires. And this is how we connect components to the Arduino. So these are all stuck together in a big ribbon. And we can actually peel these apart, and we will today as we build different circuits. You have a breadboard, which is a prototyping area. It's a prototyping tool for components. So anything that you see that has pin headers, like these have little pokey ends to them, can actually get stuck into the breadboard. We'll go over how to use this appropriately. And then we can actually prototype a circuit or build a circuit without having to solder anything and make it permanent. You have a, let's stick with this. You have a bunch of LEDs, and they come in this scary bag. They're not, you don't need to pay attention to the caution. You dump them out. And LEDs are essentially fancy light bulbs you can think of. And we'll talk more about those when we get to building our first circuit. You have a servo motor. A servo motor is a smart motor. So it's something that we can tell it, instead of a continuous rotation like you would get from a fan motor, for example, you can tell it to go to 90 degrees and it will turn. This hub will turn to 90 degrees and stay there until you tell it to go somewhere else. Speaking of motors, you have 2 of these, so hobby geared motors. These are continuous rotation, but they are geared. They have gearboxes in them. So there's some torque to it, meaning that we have power to use, and we can do things like add wheels to it and build a little robot. It can pull, it can turn a pulley or something like that to make things spin. And we use this little guy to control that motor. This is a motor controller. It allows us to change the speed and direction of the motors, of the continuous rotation motors. It's really important, especially if you're wanting something to go forward really quickly and then turn around and come back. To build this, basically build a single chip on a breadboard would take up almost this entire breadboard and about our 2 hours to teach you how to do it. So we're really happy that this thing exists, because it means just us plugging it in, plugging in a couple of wires, and we're good to go. You have a moisture sensor. So this is a sensor I can take and I can stick in some dirt. or soil. And then I'm going to add wires here back to the Arduino. And it can detect how much moisture is in the soil. It doesn't always have to be soil. This can actually double as a touch sensor as well. So if I put my fingers across here, it will detect because it works on how conductive something is. You have an ultrasonic distance sensor. So this is a distance sensor that sends out high frequency noise at one of these eyeballs, and then listens for an echo to come back in the other one. And it calculates the time between the two, and then it gets distance from that. So that's ultrasonic distance sensor. Some resistors of 2 different values, and you can see here in the inside, their values are printed, and the text is 2 different colors. So you should have a 10K, 10,000 ohm resistor, which is a green printed text, as well as a black print, which is 330 ohm resistor. These are also, if you mix these together, you can also tell the difference based on their color stripes. And we'll talk about those in a bit. And a light sensor. So it looks like an LED that got stepped on, or a light bulb that got stepped on. Has a little tire tracks on the top. This is essentially a really tiny solar panel. That's what it is. And then you guys actually have a PIR, or a motion sensor, similar to one that you might see in like security systems in classrooms and things like that. It's a little dome. I need to actually go and find mine. I don't have it here in front of me, but we can work with it a little bit more later on. I'll go find it. That's all of the parts I have. And by the way, I do have the chat window for all panelists and attendees open. So if you do have a question that you would like to pose to me real time, feel free to do so. Just open up the chat and type in the panel, type it in. I bet you're not the only one that has that question. So a little bit about, switch my camera, a little bit about Arduino. So Arduino was invented around about 2005. So what is the black 3-pin thing with the light sensor? Black 3-pin thing. Came with the light sensor. Oh, it's a temperature sensor. You also have a temperature sensor in the kit as well. So it's like a half circle. So that is a temperature sensor. And I'll grab it. Not a problem. So Arduino was invented around 2005. It came out of it's no longer in existence, but the design school in Ivrea, Italy. It was a design school that students were really tired of making mock-ups of like the newest cell phone but then they didn't have the technical competency or understand how to actually make it work. So a bunch of professors got together, invented Arduino, which takes essentially what used to be 4 years of electrical engineering and some computer science in there, and now made it accessible and available to pretty much anybody and everybody to really accelerate that exact idea that electrical engineering is not just for those with degrees, but anybody can use it. Farmers can use it, dancers can use it, whatever. And so that's where Arduino's come from, and it's changed the landscape of engineering electronics across the board, not just in hobbyists, not just to build in school, but there are professional people that use Arduino in their products every day. In fact, there's now stuff on Mars that has been programmed in Arduino. We'll talk a little bit about that later.